minutes to spare. So before I go on, I'm going to have a very quick look at the chat and see if there's anything I missed. And if anyone wants to ask me something very quickly before we move on to our next session, feel free to do so now.
Hi, Davida. I just wanted to mention that the meeting that you gave the shout out to in Mexico that we all went to, that it was really revelatory. It's going to be in Hawaii next year. And yes. I know I can't go because I've got a commitment to my new grandchild that I can't break. But I figured I've told all about it. I think some of the people in Hawaii might want to at least attend.
Absolutely. So we'll let them know, because like, folks, honestly, it blew my mind. I've spent my whole career talking about antibiotic resistance and water and how terrible it is. Going to that meeting showed me how antibiotic production is tied to the economy and communities and work, and how it's not as simple as all that. And so it unraveled some lines for me that I hadn't been thinking about. It just showed me a bigger picture that I wasn't aware of, frankly. So
it's a very, very big global meeting too. I mean, thousands of people are at this meeting.
Yes. So I would highly, highly recommend it, even if you just go to one. But like, Hawaii would be lovely to go to, frankly. And you could connect with the folk in Hawaii while you're there, which would be wonderful, right? So if the folk from Hawaii want to go, that'd be great. We'd love to see you all there. I know it's a bad time of year. It's a bad time for
there will be a kind of pseudo censor session because Brian and Sarah
are going. That's right.
There, yeah.
That's right. I love Katiun says the chemical database cross-site curriculum is much needed. Yes, it is. And so Katiun, fair play to the new school. That's where I met HBN. And so the FARS database, the plan will be to have a Hispanic serving institution, smaller version of that would be freely accessible to HSIs, where they can both use the database and contribute to it. So it'll be great. And we're trying to align it with the ACS standards and everything else, so it'll work not just for us, but for the agencies as well. They'll be looking at what we're doing. And Sarah Prescott, yes, she'll be involved, Pat, because she's the editor of the Beyond Benign's curriculum now, and we're working with Beyond Benign. So when I was in those meetings, I was like, so do you know Sarah Prescott by any chance? And she was like, yes, we do. Those of you who don't know Sarah, she is the director of BioQuest. As I mentioned before, which has unfolded Cubes now. We're on Cubes, and it also has unfolded the core source book I had mentioned to you, or the manuscripts I had mentioned to you, the publishing open education resources venue I'd mentioned to you as well. So let me see if there's anything else I need to say in there. Yes, and so if any of you are going to NABT or ASMQ or any other meetings in the fall, will you let us all know? Because it'd be great if we could meet up and kind of connect with one another, because sometimes we go and we just find each other there. But if you are going to any meetings, let us know. And as I said, your homework for today will be to finish that ambassador survey for me, so we can reach out and get you all to help us with various things, and so we can help you too. All right. Okay. So on we go. So Bhawani, is Bhawani with us?
Yes, I am.
Oh, you are there. Okay. Sorry. I can't see everybody. There we go. All right. So we are going to go on, because it's almost half past. So we're going into our second session now, which is the Wickedest Problem Part 1, the Global Civic Challenge of Water. And we are going to start with Bhawani. And just to give you all a plug to her, because she won't plug it hard, but this book is epic. I've read it. It's an amazing book. I'm encouraging her to make resources to go along with it, but I think all of you could do so too, and have some materials from the book and contribute some resources to go along with it. So highly recommend it if you're adding a book on water to your curriculum. I am not a shareholder in this. I don't get any kickbacks. It is an excellent book. I highly recommend you read it. Okay, Bhawani, I'm going to let you share your screen so you can do your talk.
Thank you, Davida.
You're very welcome.
Hold on, let me get this right. Okay. Are my slides visible?
We see you.
Okay, great. So thank you so much, Davida, and thank you for that plug for my book. And I also just want to thank Censor, Eliza, and Davida for this honor of being a Censor Water Fellow. It means a lot to me, so thank you for that. So as Davida said, what I'd like to do in this time that I have is to share quickly how I've used water as a way to help my students. So I'm a chemist by training, and I teach chemistry courses here at Eugene Lang College. of liberal arts at the New School. And one of the things that I've tried to do in teaching chemistry at an institution like Eugene Lang College is to help students see the relevance of chemistry to the world around them. And in particular, as many of you know, chemistry is often a subject which students struggle with, is trying to understand what does the molecular scale have to do with the world that they engage with. And so I've been using water as a context to help students connect the molecular to the macro to the social scale. And this slide here is really trying to help, which really demonstrates sort of the social significance of water. We all have a relationship to water. And in particular, one of the things that I think we often don't pay attention to is while water is essential for life, from a human perspective, from a public health perspective, it is access to safe drinking water and sanitation, which is critical to underlying and supporting healthy communities. And as you all know, the SDG 6 focuses on clean water and sanitation as an essential requirement for healthy communities. And so sort of framing it this way to students immediately helps them think about, well, what is it about this global challenge that we face? That even in the 21st century, we have such a staggering number of people across the globe that lack access to safe drinking water. And so these are some key facts from the WHO that really highlights this challenge that we face. And not only is it something that is it a concern of microbial or biological contamination, but increasingly an awareness of chemical contamination. And so really, again, sort of helping students think about what is it about this challenge that it's just been such an intractable problem, as the title says, this wicked social problem that we face. And for students that we teach in the United States, it's also to help them recognize that this is very much an issue, even here in the United States. SDG 6 is something that we want the students to pay attention to because, as Davida pointed out, there are communities in Texas, there are communities across the nation that have historically been left out of the infrastructure, that don't have indoor plumbing. But there's also growing concerns in the United States around communities that are just not having the capacity and the funding resources to meet drinking water regulations, and often have violations to them, not because they don't care about it, but just because they don't have the capacity and the expertise necessarily to meet the standards, and routinely receiving boil alerts. And so again, to sort of help students see what is it about this water molecule that has this challenge, I sort of approach it in helping students think of what I've framed the paradox of water. And so one of the things as a chemist, as I began to explore how to teach an introductory level chemistry course, is to help students see why is it, they all know that water is essential for life. They all are probably aware that there's this global challenge around access to safe drinking water, but to help them explore on a very deep chemical level, what is it about water that has this paradoxical behavior? Why is water essential for life? What is it about the H2O molecule that makes it the universal solvent? And the same property of it being a universal solvent is also why it is very susceptible to contamination, and both chemically and biologically. So again, we need water, but it's this challenge around access to safe drinking water, which is really underlying and supporting the importance of public health and economic and social and educational opportunities for communities. And so I've been using this frame for a while now to teach an intro-level chemistry course. About a third of my course uses this challenge around access to safe drinking water as a context. And so just very quickly, without going into too much detail here, I've tried to frame this unit using some guiding and framing questions that you can see, I hope, go from the molecular scale to the social and policy scale. And on the right-hand side, you can see the key concepts that you'll probably be familiar with, and sort of helping students understand how they can, why is it important for them to understand the nature of the hydrogen atom, the nature of the oxygen atom, how it comes together to form the water molecule, which then dictates its properties that makes it the universal solvent, both necessary for life, but also paradoxically, potentially threatening life. And so in order for me to sort of extend and help my students understand these connections between the molecular scale and the social and policy scale, is how this book came about. So I did a lot of research trying to understand how can I frame water management around this need to recognize this paradoxical behavior of water. My argument being that I don't think we pay attention to this inherent chemistry of water and how we manage, use, and treat and respect water. And so this book tries to make those connections. And I think it is because of this work that Davida and Eliza asked me to become a water fellow. So I'll spend a few minutes now pivoting as to how I see this work that I've been able to do so far now extending into my role as a water fellow. So one of the things that in doing research for my book, I became very interested in potable reuse of water, that is using wastewater and treating it to advanced treatment levels and making it safe for drinking water. And again, there's sort of a paradox there where how can you use such a contaminated, polluted source of water and making it very pure? In many ways, there are arguments that one can make that it can actually result in water of higher quality than our conventional drinking water systems are currently able to do so. And so this made me sort of think about, well, what is the role of water reuse in addressing, is there a role for water reuse in addressing this civic challenge that we face around water management? And so this image here comes out of a public brochure from Cape Town, South Africa, that you might be familiar with, actually almost ran out of water a few years ago. And so how their experience with running out of water actually has encouraged them to rethink their water management. And so this image here is basically trying to help communities, the public, understand how we already have a natural water cycle that we currently rely on, and how can we now be more mindful and respectful of the fact that we are extracting water at rates that the natural systems cannot replenish, as many human activities tend to do. And so how can we then have a more circular approach to our water management? So the idea being that whereas before we just took the water, we used it, we treated it, we dumped it back into the local bodies of water, which have their own challenges as well. How can we now use current 21st century technology to reuse that water and treat it to basically the quality that's needed depending on what the end use is? And portable reuse is very much something that Cape Town is beginning to consider approaching. So there are many potential benefits of water reuse, again, sort of helping reframe it as a more circular approach than a linear approach, augmenting the natural water cycle. It lowers stress on water sources. Many of you probably heard about how extraction of groundwater has actually affected the tilt of the earth. And so we can see the huge impact groundwater extraction has had. It provides some climate resiliency. There's also a significant fraction of the wastewater across the globe is actually discharged untreated. So that has huge public health and ecosystem health impacts as well. And there's also recognition that actually recovering of wastewater has some environmental and economic value. And ironically, water reuse is something that we have used as a society since the Bronze Age, where in fact wastewater was used to support agriculture, recognizing the nutrient richness of the wastewater that over the hundreds and thousands of years we sort of shifted away from. And now we're sort of beginning to recognize that in fact there is a real potential here in wastewater reuse and addressing some of the challenges we face today around water management. As with any solution, there's also challenges, and so we need to be mindful and to pay attention to some of those. These are extremely infrastructure intensive, they're expensive, they demand expertise. And so if you were to implement these, there are huge issues of equity that we need to be paying attention to as if we were to move forward as a society to implement water reuse in our water management strategies. So I do believe that water reuse is a sensitive topic. I think much of what Davida just talked about highlights this idea, but from an educational perspective, water treatment in general relies very heavily on physical, chemical, and biological principles. And so this allows our students to begin to see how what they're learning in the classroom applies to a social relevant challenge that we're facing, introduces principles of systems thinking, circularity, all these key outcomes we want students to be recognizing. There is a global increase in water reuse as we're dealing with droughts from climate change. as we are experiencing water extraction at rates that natural systems can't replenish. And there are huge social justice, economic issues that we have to pay attention to. So it just seems like a really rich area and topic for students to engage with as they consider the kinds of professions they might want to go into, as well as just recognizing the importance of public education so that they understand what both the benefits and challenges of water reuse. So just very quickly, as Davida said, that one of the things that this, as water fellows, we're trying to also raise is how what is happening in the global south that actually is meeting a lot of these challenges today, and how approaches there might actually be relevant for the rest of the world to pay attention to. As Davida pointed out, Bangalore is sort of a head start in installing guidelines where new buildings have to have a water reuse system built into it. And so this text here comes from a 2018 report, which actually highlights the importance of water reuse in many nations in the global south, where tragically a lot of the water is actually discharged without being treated. And so again, there's a huge potential benefit for cities that take the lead in addressing, in implementing water reuse systems. So this summer, I spent some time to sort of learn about what's happening. I come from India, but I've been away from it for a long time. So going back and understanding water management issues in India was actually really important for me personally. I spent my time in Chennai, which happens to be a city in the southern part of India, in the state of Tamil Nadu. Chennai is a heavily water-stressed region. They have also instituted mandatory wastewater reuse in new construction. They actually have been requiring industries for a while to install water reuse systems. And they're actually now moving to something called a zero liquid discharge, which is a highly technically sophisticated approach, which I'll talk about in a minute. I spent time talking to academic experts and to other water management experts in the city. And some of you may be familiar with the Indian Institute of Technology. These are the premier engineering institutions in India. I spent some time with faculty in Chennai who are actually looking at water management. And the IIT in Chennai has actually put into practice the work that they're doing as researchers. They have, because of water stress, installed a water reuse system within the campus. And they're completely independent now of municipal water, and they're actually able now to send water into the municipal system. So a really great example and a case study of how they're putting their research into practice to help sustain their own campus. The other really fascinating case study that I came across was in a huge textile area in Tamil Nadu, in the city of what's called Tirupur, which is one of the major leading textile industries sites in India. And as some of you may know, the textile industry is a highly polluting industry. And as a result of the impacts of the water in the local community, they actually were required to shut down the textile industry here because of the huge contamination that was happening in the local community. This clearly had huge economic impacts because the town relies on these textile industries. And as a result of the shutdown, through a public-private partnership, a very impressive zero liquid discharge system has been set up in this region. So I've just begun to learn about it, but I think this would be a really important case study of how manufacturing sites are now beginning to pay attention to the environmental and public health impacts, and how there are ways in which they're trying to address this through 21st century technologies, as well as paying attention to what might be the impacts on local communities. So I have a lot to learn here. This is just a start. But what I'd like to do as part of my Censor Fellow is to really develop some case studies that can be used in classrooms that connect the scientific principles around water management to these real world applications, looking at potable reuse across these are some places I would consider looking at, and then using the industrial reuse in Tirupur as a really, I think, an interesting case study of environmental sustainability in the textile industry. So again, I'll end here. Thank you all for your time, and thank you again, Censor, for this honor.
Thank you, Bhawani. We have time for a minute or so of questions if you want to ask Bhawani anything. Does anybody want to ask anything to Bhawani? They're burning to ask her a question.
Robin has her hand up.
Robin, go for it, Robin. I can't see. I'm wearing glasses now, so I'm slower than usual.
I was clapping.
Oh, you're clapping.
but
okay.
but I will just make a comment, and that is Bhawani as a fellow chemist who teaches about water in a couple of courses, not only in general chemistry, but also in a course I teach called Snack Science, the science of food and cooking for non-science majors. You've just given me that phrase, the universal solvent. I don't know. It's just such a succinct way to convey a whole lot. And I've never used that term. I've used that it's a great solvent. It's a wonderful biological solvent. And maybe it's because of my partial background with organic chemistry that I don't think of it as the great solvent that it really is. And so thank you. I'm going to take that and run with it.
Thank you for that.
Anyone else have anything? Well, I just get my stuff going here again. All right. Okay, let me see. All right.
If you got a second, Robert had his hand up.
Robert, go for it. Right. Robert,
Judith
go for it
as well.
Okay.
Aloha. Yeah, this is fascinating and so well and very clearly presented. Thank you very much. I just think there's going to be a lot of public media knowledge growing. How do we convince the public that this is the way to go forward? Because the sooner we get people to vote on these things and understand that these issues are coming, the more funding hopefully will flow to these questions. And I could see where getting started on the media story here would be very important. Thank you.
I'm stealing that. Funding will flow.
Judith has her hand up.
Go for Judith.
Just needs to unmute.
I'm interested in the part of paradox of water. They
might be having some connection issues.
We can't hear you, Judith, unfortunately. Maybe Judith, you could type it in the chat if you would like. Sherryl, you might help Judith with the chat there if you can. There we go. All right, folks. So
I was sorry.
Is that Judith speaking? I'm not sure.
Yeah. Judith.
Okay, because I have to keep going. I'm sorry, Judith. I'm going to ask you to put it in the chat for me, and we will answer your question as soon as we can, if you don't mind putting it in the chat for me. All right, so we are going to go on to our international fellows. So as I mentioned to you before, our first round of funding allowed us to recruit some national fellows that had international ties, and we specifically focused on folks we knew were doing amazing work in the realm of water. And so we've now recruited some international fellows, and these are folks that you'll be hearing about a lot in the coming months. And the first one who was with us last night, I don't know if she's here today. I don't know if you're here, Rohini, but I just want to introduce her. She's Rohini Pradeep. She's project manager at CDD. She is an environmental engineer. She's going to be working with us with Shrey as well, and probably Bhawani too, frankly, on looking at ways to study antibiotic resistance. So one of the things that Bhawani didn't mention, but is something that the microbiology folks are very concerned about, is with respect to reuse of water, is antibiotic resistance genes, markers, and the bacteria themselves. Current water management strategies don't remove these from the water. So as water is being reused on farmland, or the sludge is being reused on farmland, et cetera, it can carry antibiotic resistance with it. And the EPA has actually put out a bunch of funding calls. I'm working on one right now to actually look at this. So it's becoming a critical thing, but we don't test for it environmentally. We don't test for it at all. So we have no data really other than pockets of papers here and there across the country. And we learn a lot from what's happening in different parts of the world. So Rohini is going to be doing it. She's working in, you guessed it, Bangalore. We have a strong Bangalore connection here, but she's going to be using Bangalore's case study to look at antibiotic resistance specifically and how the reuse strategy that they've done is impacting water reuse. So I'm very, very excited to see what she'll do. And as I'd mentioned to you before, she may be coming to our water event, which will be in November. So if any of you are interested in coming to that, let us know, because we're trying to get that up and running off the ground. The second one is Florencia, and Florencia actually has a talk. So I'm going to stop sharing and I'm going to pull up her video if you'll just bear with me. Okay. Share. QuickTime Player. I'm going to talk to myself as I do this. All right, here comes Florencia.
Hello, my name is Florencia Cancela. I'm a biochemist, PhD student in biological science, and assistant professor at Faculty of Medicine in Uruguay. One of the research lines we develop at our lab focuses on wastewater surveillance of viral pathogens. Next, I will briefly describe our recent projects. SARS-CoV-2 wastewater surveillance is acknowledged as a useful, cost-effective tool for monitoring epidemic waves. In our recent published study, we mainly analyzed the different viral lineages and their distribution over time. For that, wastewater samples were collected from December 2020 to July 2021 from Rivera City of Uruguay at wastewater treatment plants, like the one shown in the figure on the left. The samples were concentrated with precipitation method by polyethylene glycol. The RNA was then extracted concentrates, and the virus was detected by real-time PCR. Then we amplified a region of the receptor binding domain and sequenced it through ion torrent next-generation sequencing. Firstly, it's worth mentioning that in Uruguay, were described two major COVID epidemics, one between April to June 2021, which is the one depicted on the figure 1A, associated to gamma VOC, variant of concern, showed in figure 1B, and a second wave associated to Omicron VOC from December 2022 to January 2022. Figure 1C shows the variant frequency of the different amino acid changes detected in the wastewater samples in this study. Remarkably, from February to July 2021, the amino acids K417T, E484K, and N501Y were the dominant ones, indicating the presence of the gamma VOC. However, according to epidemiological report from public services in Uruguay, this VOC was not clinically detected until March. Additionally, wastewater samples were collected from 4 cities during July 2021. In all cases, the 3 mutations mentioned previously were present at a similar high frequency. Samples from Rivera City were the ones with the greatest heterogeneity. Therefore, these works show that the early detection of variants before being detected in patients can be very helpful in order to make informed public health decisions. Currently, we are finishing the project of wastewater surveillance of hepatitis E virus, known as HEV. HEV is an emergent zoonotic disease of increasing concern in developed countries. Our group has previously described the prevalence of HEV genotype 3 in human clinical cases, wild boars, and captive white-collar peccaries from Uruguay. In this work, we analyzed wastewater samples from 10 different places throughout the country and processed the samples as described for the SARS-CoV-2 project. By real-time PCR with specific TACMAN probe, we obtained 10 out of 86 positive samples, which represents a prevalence of 11.6%, all belonging to the same city, Melo. We were able to successfully amplify by RT conventional PCR and sequence 2 of these samples. The phylogenetic analysis showed that these 2 sequences grouped in genotype 3 in a separate monophyletic cluster with our previously reported strains from animal reservoirs and clinical cases. Our nucleotide analysis of partial sequences and complete genomes of HEV strains indicate that the Uruguayan sequences represent a novel subtype, named 3O. As perspectives, we are planning to carry out wastewater surveillance of respiratory syncytial virus, influenza virus, and monkeypox virus. This is our research team, and I would like to thank the following founding agencies and public services.
Thank you, Florencia. I don't know if she's here. Hey, Florencia, thank you for your talk.
Hi, thank you for the invitation.
Does anyone have, Florencia's with us, does anyone have a question, a quick question they'd like to ask her? And as I mentioned, we will have Florencia in person in Texas in November, should you want to meet her. And Monica, as I said, Monica is the person who gets all the credit for connecting us with Uruguay and getting that project up and running. And she will be collaborating with them on further gene discovery and everything else with respect to the wastewater. So watch that space. They're doing excellent work. All right, I'm going to bring us on to our next talk, which will be Luz. I'm going to bring Luz up now. Okay, share my screen.
Hi, my name is Luz Breton, and I am researcher at the Biotechnology Institute of the National University of Mexico. And today I'm going to talk about understanding our water resources, knowledge, and powers. For the past 5 years, I have been working on Cuernavaca, a small city located 2 hours away from Mexico City. And the place is all about water, with stuff like farming flowers, raising fancy fish, growing veggies, and even having a bunch of water parks around. Water resources play a crucial role in my city. So I have spent my days doing research in the local river called Apatlaco. Our findings have revealed elevated levels of some nutrients like ammonia, phosphate, nitrate, salt, and even heavy metals like cadmium and lead. So I wanted to know more of the pollution in this river. In the lab, we love next generation sequence and bioinformatic analysis, and we have used them to reveal what kind of microorganisms lives there. The results show that we have bacteria that could be a potential risk to the people who live around. For us, it's very important to understand this ecosystem and their microbial communities. All of these analyses, which contribute with new information about local water resources, are conducted in collaboration with my students. Undergraduate and postgraduate students visit the lab to gain deeper insights into environmental microbiomes and their connection to pollution and health. For me, it's very important they can understand their own city, their own resources. I think it's the only way they can preserve this resource. I also take an active role in training adults from rural communities facing water-related challenges. So along the year, I conduct a workshop to educate them about their water resources, how to preserve these resources. We also teach them some eco-techniques that can be applied in their communities. Because many of these people didn't have the opportunity for a higher education, but that should limit their ability to make informed decisions about their environment and about their own resources. Currently, my projects are focused on understanding the microbial communities of several rivers across Mexico. We want to correlate the water quality with the microbial community, with the health of the people living in their vicinity. I also know how this water quality impacts in some farmlands. See you later. Ciao.
Wonderful. Is Luce here? I don't think she is. Well, I'm extraordinarily lucky because I'm getting to host Luce in Temusa for 3 months. She's coming to the lab in August, so I'll get to see her for a long time. And to be honest with you, if any of you remember what I used to do, Luce is doing it, but on steroids, and she's showing us how to properly engage with the community. And I'll be learning from her when I try to engage with the local Texas communities down here, to try and help them with their water concerns as well. And again, given Texas's issues, we've talked about legislative and everything else overreach. But water is frankly a huge problem in Texas. It's massive, and private ownership of water is a huge concern in Texas as well. So even the biogas that's being made is being sold, and it's not necessarily coming back to us. So it's a huge concern. So I'll be learning a lot from Luce. So I'm excited to work with her. All right, so on we go. We are going over to the Wiser team now. Give me 1 second so I can pull up this video.
While you're pulling it up, Sherryl here. I just want to say that for timing and technical issues, I was narrating it, and I wish Kennedy and Judith had been able to, but they are here now. But it was absolutely a team effort. I just had the easiest tech to get access to. So.
Gotcha. Okay, I'm going to share my screen one more time. Bear with me, and I apologize that I can't get the volume any higher. It's just because I have a puny little laptop. All right, off we go. And continue to put your comments in the chat, folks. We'll catch up with you as soon as this is over. Okay. Let me know.
Hello, everybody. My name is Sherryl Broverman, and I'm delighted to talk to you today about water quality and community science by adolescent girls, the Wiser Water is Life program. My colleagues in this program are Kennedy Makula, a teacher at the Wiser School in Kenya, and Judith Obiero, also at the Wiser School in Kenya. I wish they could be here on this presentation with me, but they are currently back in Kenya. The Wiser School is a program of the Wiser NGO, a non-governmental organization, and the mission of that organization is to produce the highest outcomes from the hardest to reach girls. So we work in rural Kenya. The orange circle indicates a peninsula sticking out into Lake Victoria, right at the Tanzanian border. And as we talk about water, we have to talk about Lake Victoria. Here's a larger picture of it zoomed out. It is the largest lake in Africa. It supplies water to 30 million people in Kenya, Tanzania, and Uganda, making international collaboration on water quality issues a critical issue. And large volumes of wastewater are discharged into the lake from domestic, industrial, and agricultural sources. In this diagram, you can see how population density around Lake Victoria has changed dramatically from 1960 to 2015. And particularly if you look in the part of Kenya, you can see that it is at very, very high density and has been for quite a while. If we zoom in on that area again, just to help you localize where this project is happening, there is a little peninsula sticking out right at that border, and that's where the Wiser NGO has its campus and its programs. So in Kenya, 59% of people have access to clean water. That is an average over the country. It is probably more problematic in the rural areas. 29% have basic sanitation, even less in the rural areas. And of course, this feeds back onto why people don't have clean water. There's a lot of open defecation, not a lot of good sewage system, and very few water treatment plants outside of major cities. 20% of people drink water from contaminated water sources. This is a picture taken by one of my students of young people in Kenya collecting water from a drainage ditch. The yellow arrow points to someone bringing water home to use for the evening meal. People are highly educated about the need to produce clean water. Sometimes water access alone is a problem, but when that gets home, it will probably be filtered or boiled, chlorinated, and sedimentation, but that certainly isn't always sufficient. So access to water is a challenge if you're away from the lake, and access to clean water is a challenge for everybody. Fishing is the main economy around this part of Lake Victoria in Kenya, and commercial fishing happens at night. That is critical because the men are out in these boats on open water for 8, 10, 12 hours, and they basically have to hang over the side of the boats in order to use the toilet, so it's open defecation into the lake during night shifts. These are fishing boats at the lake right near the Weiser School where this work is happening. So this is one of the fishing beaches. The fishermen use lights at night to attract the fish. So every bright light you see, this is also taken from the Weiser campus, is a fishing boat out at night. So you can see there's quite a dense population of these boats out at night, all night, without any sanitation except the lake. Now, this is the same lake the next day where people come down to fish, to bathe, to wash their clothes, to wash their dishes. Girls traditionally are the main sources of water in the lake. They are the only ones that are considered culturally appropriate to carry water, to bring the water for dishes, to bring it back to the house. You can see many people bathing there. Again, this is the only source of water. Water is a gendered issue, partly for the amount of time that girls spend in the lake, as well as around the lake. And if you're away from the lake, it will be your task starting around 8 years old to go and collect water from the lake to bring back to your family household. So girls might spend 2 to 3 hours, sometimes each way, to collect water from the lake. This has a dramatic impact on their lives as young girls and adolescents. It certainly interferes with schoolwork. They might do 6 extra hours of hard labor and chores compared to their brothers. It makes them more tired, particularly in an area that doesn't have all its nutritional needs met. It has a dramatic impact on gender-based violence, as girls spend a lot of time walking alone, often at dawn and dusk, and around the lake where a lot of the fishermen congregate. And around Lake Victoria, in this part of Kenya, there's a 25% HIV rate in the population, in part driven by the fishermen. And so this increases a young girl's HIV risk. Just the fact of having to collect water has multiple impacts on her education, her health, and her future life. This is a picture of the Weiser campus. Our flagship program is the secondary school for 240 girls. We will soon be opening a junior secondary, basically middle school for 7th and 8th graders. Most of the students who attend the school are the first in their family to go to secondary school. This is a dramatic achievement for this community to have so many girls in school. And given the high HIV and malaria and cholera and typhoid rates in this community, unfortunately, 40% of our students are orphans. But they are also amazing, kick-ass is the only word I can think for them, dedicated, hardworking girls that come from a fairly poor performing school district, but end up over the last 10 years being some of the top competitors for scholarships to university throughout the nation. So once they're in the Weiser School, they just fly. One of Weiser's missions is to empower girls through education with a strong focus on STEM and health. And in order to do both, but particularly the second, clean water is critical. So starting in 2008 with funding from UNICEF and then follow-up from USAID and then leadership from local community members, Weiser implemented a clean water production and distribution system. The blue triangle you can see in this Google Earth image is our campus. And we put in a pipeline that pulls water from fairly far outstream away from where people are bathing around the lake and pumps it up to the Weiser campus, where it goes through sedimentation, filtration, chlorination, and then gets distributed out to the community. You can see the Mahuru Health Center. That's the only Ministry of Health clinic and hospital in the area, and they get 100% of their clean water from our system. Wiser also pumps water out to multiple schools in the area, and particularly inland, so that girls don't have to walk so far in order to get water. This is the sedimentation area where before it goes through a sand filter. This is our principal, Madam Dorcas Ayugi of the school, working with an engineer. This is what the water looks like when it comes up from the lake before it goes into sedimentation and into an underground tank. After it's finished being treated and chlorinated, it gets pumped up to these two water towers, one for more local delivery and one with higher pressure to go even further inland and slightly uphill. On the right, you can see a clean water kiosk, the blue and cream kiosk. This is one outside the Ministry of Health clinic, and those are now located throughout the community. We have filtration and pumping capacity to serve 15,000 people in the community. This is a Google Earth map of our clean water distribution kiosk. You can see Wiser underlined in pink in the center, just inland from the lake a bit. And our Wiser our students, once they're alumni, are involved in research projects, interviewing households throughout these communities. And of the over 1,000 households interviewed, 92% report a reduction in diarrheal diseases and all digestive problems when using water from the clean water distribution kiosk, which is really exciting. 21 schools and homes have also paid to have clean water piped into their houses. But we are also a school that have chemistry and biology laboratories that are equivalent to many Kenyan universities, and active learning and sophisticated pedagogies are a critical part of Wiser's success with our students. So together with the Water Fellows program through Sensor, my colleagues in Kenya and myself, we have come up with our new project. The first is to develop Wiser's campus as a center for community science water quality testing. We've done a feasibility study of the infrastructure already on campus and identified what needs to be developed. I can't wait to welcome my colleagues from Kenya onto Tamusa's campus and with Davida, hopefully this coming fall, as we identify the equipment and the infrastructure building we need to do. We want the girls being involved then as community science projects, as well as laboratory class projects to document water contaminants, looking at microbial, perhaps doing some genetic information amplification, as well as chemical and heavy metal in the area, as well as monitoring the water coming out of our system for different levels of chlorine that might affect taste or utilization by the community. We have a strong goal to develop girls in STEM, and we're hoping this will encourage more young women to go into water science, whether it's chemists or microbiologists. Kenya is just starting to do wastewater epidemiology with COVID and with polio in some of the cities. And we hope we can develop young women that will become the next leaders in women in water science. We, of course, want to develop new pedagogies, not only for our own school, but to be shared with other schools in the Global South, particularly those with lower resources, that can be done to start educating community members about the water in their area and be able to monitor potential outbreaks. And finally, develop a case study on water as a gendered issue for use in the Global North. This one was completed this summer, and we hope to be releasing it soon. So there's a lot to do. I'm very delighted to have these phenomenal.
It cut off before I could thank Judith and Kennedy, and I apologize for that technical glitch, but thank you.
Well, how about we do it now? How about you do it now? Judith and Kennedy are here, so we have time. Go for it.
Kennedy, if you'd like to add anything, please do.
Wow, thank you so much, Professor Sherryl. I think this is really excellent. You've captured almost everything that we would have wished also to air at this moment, but I'm glad that we had done that earlier. I would have wished to add, especially on the part, there's a slide that's a photograph of what happens at night during fishing is taken from Wiser campus. I wanted to add that the fishing is done using kerosene lamps. Kerosene or paraffin is a petroleum product, and during fishing, in most cases, you'll have this kerosene end up spilling the water, and all this agate is drunk when water is fetched and this water is not treated. Further, I wanted to add that one of the challenges that we have with the supply of safe water through our partnership with the community is the element of sustainability. We really hope that if we could have resources to have this water spread to a greater percentage of users in the community, then again, what we would get from the users as they pay for, of course, the subsidized price would help again in managing cases that rise as a result of maybe breakages of pipes and the operation costs. So that we've not been able to achieve so far as of now, because slightly above 50% are the ones that can easily access this water. So that is one of the sustainability problems that I think we have at the moment. But going into the research aspect, WISE as a school, we've always invested greatly in science and engineering projects involving our girls, our students. So we take this as an opportunity that will help us provoke thoughts of our students in the field of science and especially on water issues. It would really be so exciting having our girls own the process and also build their confidence in the use of water and conservation of the same water, and also attach value to the presence or the water that would have that is very clean at the expense of wastages that would come because they are not involved. So generally, we are really hopeful that from beginning September, we'll be having a very extensive and vigorous program with our girls and have this fused in our regular process and regular activities under science and engineering. I want to stop there and again invite my colleague, Judith, to add in case there is.
Thank you, Teacher Kennedy. The presentation was wow. What I need to add is that with the modern technology, our fresh water Lake Victoria is now undergoing serious pollution, an aspect of eutrophication because of the products coming from the industries. There is also the development of new technology in fishing. The world is being revolutionized. So in this case, most of the fishermen are now revamping what we call the caging system. And in this caging system, they're using chemicals, they're using non-biodegradable nets. All these get to our freshwater lake ecosystem. And currently, the rate of pollution is very high, coupled with the high temperatures. And sometimes at the beaches, we get pollution of foul smell due to detoxification of ammonia and hydrogen sulfide gas. So with the upcoming of the project, Water is Life, we really are interested to pick up that chance so that we can have the modern technology that we can do rapid sampling of water samples, make use rapid test very fast, get access to clean, safe water, roll it back to the community so that our girls are always safe and the whole community remains safe despite high levels of pollution with the upcoming of new technologies around our Lake Victoria that eventually embark to us in wiser campus. That's what I have to add to that.
Thank you, Judith. Wow. Okay, so that's our presentations, folks. We've got it all done. So if any of you are interested in helping out, getting involved, joining the water group, we welcome everyone. And the plan is to try and, as I said, is to integrate as much of these community projects, the research and everything else into our curricular projects. And that includes case studies. And as I mentioned before, we have that Frontiers opportunity, which we'd obviously love to have some solicitations for, but that is I'm not going to lie, it's costly, right? But we will be having at least one, if not two, of our journal, our own journal, Sensor Journal, special editions, right? That will be devoted to the work of the fellows because we got the funding for that. We have actually got funding for that. And in addition then, we can also contribute to Pat's project, which I will not talk about again, Pat, because I want to give you time to talk about yourself, but the BioQuest project and the book, right? So that's another opportunity for us to publish this work. So yeah, critically important. Any last thoughts or questions from anybody? Feel free to speak. Monica, were you going to say something?
Yeah, so I was going to suggest, Davida, what if we got people that were interested in creating like a small model on wastewater to incorporate like in a microbiology class or a introduction to biology class that had resources that could be used, let's say, you know, for freshmen or something like that, with some like more in-depth take into, like, for example, the program that we just heard about implemented in Africa. But it could be built like on a module kind of approach where people can, you know, pick and choose. But, you know, I think that I'm talking about myself now. When I teach, I have ideas, and sometimes I'm like, oh, it's so much work that I cannot put it together. But if we created a small group, perhaps we could help each other, push each other to get it done. I don't know.
I was just going to say, this is so great to see, especially the Wiser stuff really did have its little nugget in early sensor, but also Davida, it's your and Monica's wastewater that attracted the funding for us to go global like this, to start spreading out and having the research feeding our educational mission. So I have to thank, you know, from little acorns, great oak trees grow, but it's our people that make this happen.
So we have, Monica, with the water grant that we recently just got, we have funding in there to do exactly what you just described. So the plan was to establish a working group of fellows. This is a different grant, it's an NSF grant, to develop water-related curriculum for intro courses. And so we're going to start with a crew in Texas, as I mentioned before, but there's funding in there to support folks from Sensor to help with that. And just as another plug, what is it, Carolina, the company Carolina actually has a demo, a very basic demo of a water wastewater treatment plant that they actually started to sell. It's only a demo, but it just goes to show that there is interest there to kind of integrate this into the general curriculum from the companies that make the materials for classes, right? And so instead of it being a demo, I was like, well, you know, we could integrate it into fermentation labs, and we could integrate it into sedimentation labs, and it could be in more than just micro. It'd be great if we got it into Gen Bio, Gen Chem. And so the question is to persuade our colleagues, right? So who want to do it. But I love the idea of the modules, and that's definitely something we'll do for sure. Anyone else? Thank you, Carrie. Yeah, I saw it at NABT. I just walked up to it and it was there, and I was like, this is the greatest thing I've ever seen. But again, it's like it's not real. It's a demo. It's like colored-y stuff, you know. It's not like a real thing. But I think we could definitely do it. And I've been, just for the record, folks, I've been using a biodigester from K through 12 in my classes for a while now. It's just basically looking at manure and how food is broken down and production of gas, and it's very simple, but again, very tied to wastewater and anaerobic digestion. So there are loads of options for you if you want to do this kind of thing.
And I also think that, I'm sure somebody, you know, mentioned it earlier, but this has such a scary connection to climate change, right? And it's something that, you know, usually people don't put together climate change and wastewater, but it's probably one of the first things that is going to be hit. And it's not like, you know, it's not very catchy to talk about it, but I think it's our role as educators to bring it up, right?
Yeah, and it's the way to get the funding, frankly. So
yeah.
I mean, it's crass, but like one of the things we're doing is like we're showing the statistics for the water infrastructure, our aged water infrastructure across the United States, and the bill is there, the money is there, but the water defined programs for water specifically are few and far between across the country, right? So, and for those of us who teach community colleges or in, you know, four-year schools or what have you, there's so much demand on us in terms of covering all the different types of things you could do with your degree kind of situation. So it's going to have to be something that's, like you said, it's modular, it's adaptable. I think if we have a range of things, from case studies to readings to, you know what I mean, lab activities, whatever it is, stuff you could do at home, the more options we give people, the more likelihood it is to be integrated. So and just to give you a sense of how bad it is, Northwest Vista is a school beside me. The water grant, we had originally planned to partner with them. They literally just closed the program because the program is not attracting, it's a water resources program, it's not attracting students. So I don't understand it. We have a global catastrophe with respect to water, and somehow our students are not being attracted into the field, right? And the field itself is dominated by it's an aging workforce, frankly. They don't see the jobs there. They don't see the attractiveness of the career to them. So we have to figure it out, but they closed the program. And I've just been informed that even the water program my school is on, is in dire straits as well. They're only attracting 25 students. Biology is attracting 800, water is attracting 25. So something's going wrong here. And people don't recognize it as being a critical problem. And I think if we emphasize, from my perspective, it's a little bit selfish, but if we emphasize the pathogens, the emerging contaminants part, the biological, the biomedical kind of aspects, I think it's almost more attractive to those kind of biocentered students. So it's a way to do it. But yeah, like, honest to God, every chance we get. So that's why I say, if you look at CourseSource right now, they have all these categories, right? But what Sensor folks do is we're interdisciplinary. We span multiple categories, right? So it's very hard to say which journal does it belong in, which domain does it belong in, et cetera, et cetera. So I think this is going to be a conversation with them to figure out where can we put things, and maybe we're using tags. And that's why Cubes is useful, because you can tag things. So if you make a resource, you can have on there biotechnology, hashtag biology, hashtag chemistry, hashtag humanities, whatever. And people pull it up and see that it touches on all these different bases. A water and women course, oh my gosh. Yes. Yes. Can you take point in that? We'll all join you. Okay, so I've been talking a lot. Any last thoughts from anybody? And before I let y'all go for a very quick 5-minute break.
Barely 5. We're supposed to start at 2:30 with Carl's presentation, but I think giving everybody a little break, I could really use one.
I need a break too. I need to make a contribution to my water system.
Yes.
Right now. Okay.